Built to code, never built to perform. Those are two different things. And your energy bill is the proof. When we talk about making a house more efficient, most of us start with appliances, better bulbs, smart thermostat, more efficient air conditioning unit. And those things matter at the margins. But if your building envelope is working against you, the margins is where all the effort's going to go. Most people don't know that the energy code has existed in North America since the 1970s. It's been improving ever since, slowly, incrementally, and against significant resistance from those who build houses at scale and the industries that supply them. It's never in any version, in any jurisdiction, been designed for your house to be high performance. It's been designed to meet a minimum. A threshold that made sense in the moment, balanced against what cost and what the industry could deliver at scale. Minimum and performance are not the same thing. The gap between them shows up in your energy bill every month. Your house isn't inefficient because you're doing something wrong. It's inefficient because it was never required to be anything else. The good news is you don't have to wait for code to catch up with physics to fix it. Take HVAC sizing. For decades, the default approach was to oversize the equipment. Bigger unit, more capacity, insurance against the worst day of the year. Energy was cheap and oversizing feels safe. What it actually produces is a system that short cycles, so it turns on, hits a set temperature quickly, and turns off, without running long enough to dehumidify the air. So the room hits a set temperature, but it still feels wrong, clammy in the summer. The fix most people reach for is a bigger unit. The problem is the unit is already too big. Code requires equipment. It never required the right sized equipment. Those are different requirements with different outcomes. That same pattern shows up everywhere. You switch to LED bulbs. It's a real improvement. Lower energy use. But the recessed can that the light bulb goes into is a hole in your ceiling plane. Heat and air move right through it. The insulation around it is compromised. The bulb saves pennies, and that can light loses dollars. The product improved, but the assembly didn't. It's a pattern code minimums produce. Components meet individual requirements without the assembly being required to perform as a system. Better bulb, leaky ceiling. And that result is marginal. Most forced air systems lose 20 to 30% of their air through duct leakage. Before it reaches the room it was meant to condition. It goes into the attic, into crawl spaces, spaces we're not living in. That loss compounds the oversizing problem. The system has to work even harder to compensate for what the ducts are losing. Code is starting to require duct testing. We're keeping the ducts inside the conditioned space, meaning inside the house, in some jurisdictions. But most homes were built before either of those were on the checklist. None of this is something a homeowner caused. Decisions were made before you owned the place. Optimized for construction cost, not operating cost. The question worth asking about any energy efficiency upgrade isn't whether the product is better, it's whether the assembly it's going into is performing well enough for the product improvement to matter. The smart thermostat optimizes when the system runs. It doesn't change what the system is fighting against. A more efficient air conditioning unit moves the same air through the same leaky ducts into the same poorly detailed rooms. The product improved, the performance gap didn't close. So start with the assembly. Air sealing, duct testing, insulation continuity, window specifications matched to your climate. Those are the improvements that change what everything else is working against. The products compound on top of a performing assembly. They don't substitute for one. And those don't require starting over. Sealing ducts while your HVAC system is being serviced, air sealing an attic plane before you add more insulation, addressing the can lights when the ceiling's open for another reason, targeted, sequenced, tied to work you're already doing. Your house was built to meet a minimum. That minimum was never about performance. The energy bill you're paying every month is the gap between those two things made visible. The upgrade that changes isn't the next product. It's understanding what part of the assembly is losing what and fixing that first. Everything else performs better when the assembly it's sitting in is doing its job. That's what building science is for. That's what this channel is built around. If you want to think differently about your house before you spend anything on it, start here. If you want someone to help you work through your specific house and what's actually losing and where, that conversation is available too.